Hello. Today we're going to take a look at how you can determine the value of the 6 trigonometric functions when you're given certain pieces of data, like for example, a point on the terminal side of the angle or 2 of the sides of a right triangle. So let's take a look. So let's say your first problem is to find the value of the 6 trigonometric functions when you are given that a point on the terminal side of your angle is 3, 6. And remember that this right here, the x-axis, is going to be your initial side. And so then where your angle stops is called your terminal side. So the first thing I'm going to do is I'm going to write out sine theta equals cos theta equals tan theta equals, and I'm going to write what the ratios are. So remember our SOHCAHTOA reminds us that sine is the ratio of opposite over hypotenuse. Cosine is the ratio of adjacent over hypotenuse, and tangent is the ratio of opposite over adjacent. Now, if these aren't familiar to you, pause, click on this link, go take a look at this video on SOHCAHTOA. All right, the next thing I'm going to do is I'm going to write the cofunctions for each of these. Sine's cofunction is cosecant theta, cosine's cofunction is secant theta, and tan's cofunction is cotangent theta, and I'm going to remember that each of these cofunctions is the flip of the ratio. So cosecant is hypotenuse over opposite, and you can fill in these other two. All right, that is going to really guide me. So now my next job is to say, well, okay, these are all within a triangle, right? But I have a point. Well, that's easy to fix. Let's drop a perpendicular from that point to the x-axis. Perpendicular means we just did a right angle. And now my point value of over 3 lets me know this side length value. And my point value of up 6 lets me know this side value. Theta is always the angle coming off the x-axis. And now my final, I need my h. Well, that's easy enough. This is a right triangle. We know that right triangles use Pythagorean theorem. A squared plus b squared equals c squared. 3 squared plus 6 squared equals c squared. 9 plus 36 equals c squared. 45 equals c squared. C equals the square root of 45, square root of 9 times 5, or 3 root 5. All right, now I'm off to the races. I just take this stuff and fill it in here. Okay, so my first step is to say that sine is opposite over hypotenuse, 6 over 3 root 5. Now your teacher's going to want you to simplify that. So let's bring that down here. First thing I'm going to do is say the 3 cancels with the 6, leaving me with a 2 upstairs. And now I'm going to rationalize my denominator, multiply top and bottom by the same thing by root 5. The reason I'm doing that, square root of 5 times itself is simply 5. And then on the top, 2 root 5. So my sine becomes 2 root 5 over 5. Okay, while we're here, let's do our cosecant, which is the opposite, 3 root 5 over 6. This time, I don't have to rationalize my denominator, but I am going to simplify that. And so my cosecant is root 5 over 2. Okay, let's do it again for our cosine. Adjacent over hypotenuse. 3 over 3 root 5, that's correct. Cancel those 3's. 1 over root 5, that's right. Rationalize the bottom. Root 5 over 5. My cofunction secant is going to be that hypotenuse over that adjacent. Those 3's will cancel, leaving me just with the square root of 5. And now finally, let's do it for tangent. Opposite over adjacent, 6 over 3, or just, and now I'm going to flip it, 3 over 6, or 1/2. And that right there are the 6 trigonometric functions when we have a point on the terminal side of an angle. All right, so let's do another example that isn't in the first quadrant. So let's say this time, instead of being given a point, we are shown a triangle in position and told that we're over 1, and then we also have the measure of the hypotenuse. Okay, so again, how do we find the third side of our triangle? Well, we use Pythagorean theorem. In this case, -1 squared plus y squared equals 4 squared. 1 plus y squared equals 16. Y squared equals 15. Y equals the square root of 15. Now, here is the trick. What quadrant are we in? We're in the third quadrant. We are over negative and down negative. So that is negative square root of 15, and that will make all the difference in getting your answers right. So if they plop you in a quadrant, you've got to remember to supply the correct positive negative signs. Okay, let's do this stuff again. I'm going to write all my stuff out. Okay, this time I've left the stuff out, so it's time for us to remember. Sine is what? That's right, opposite over hypotenuse. And remember, your theta is always the angle whose initial side is the x-axis, okay? So theta is not this, theta is that, and that helps us determine opposite. All right, so in this case, negative root 15 over 4, we don't have any rationalization to do, but we can see that when we flip it, and I'm just putting my negative on the outside there, now I'm going to need to rationalize, multiply top and bottom. This will become kind of a habit. You'll just look at this and go, oh, that's going to become 4 root 15 over 15, but you can also always just do it out, and then don't forget to bring that negative along. Okay, cosine, that's correct. Adjacent over hypotenuse, negative 1/4, and we flip it to find negative 4. And then tangent is my opposite over my adjacent. Negative over negative becomes a positive. That's correct. And now when I flip it, 1 over root 15, can you tell me what this is? That's correct. Root 15 over 15. And those are your 6 trigonometric functions. Okay, keep playing with this stuff. Check out some of my other trigonometry videos. Leave any questions you've got in the comments, including any school problems that you'd like me to take a whack at in a video. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.